Hello everyone. In this video we are going to be going over how to multiply polynomials by another polynomial. Let's first start off by reviewing how we multiply a monomial by a polynomial. So the first step is we need to think about this as the distributive property because that really is what we're doing here. We're multiplying one term on the outside by a set of parentheses. So this 2x, it needs to be multiplied by everything inside the parentheses. So we're multiplying 2x times x and 2x times 3. So 2x times x, that would get us 2x squared. 2x times positive 3 would get us a positive 6x. So there's just a quick review of monomial times polynomial. Now let's get into some examples of a polynomial times another polynomial. So again though, we're still using the distributive property. We're multiplying a set of parentheses times another set of parentheses. So this parentheses on the outside here, just like before, if it were just the 2, we would do 2 times x times plus 2 times 3. We do the same thing. Now we just have another term that we also need to multiply by the other set of parentheses. So we would do 2 times x and 2 times positive 3, but we also need to multiply this x times everything inside the other set of parentheses. So x times x and x times positive 3. So that way everything inside this set of parentheses is getting multiplied by everything in this set of parentheses. So I'm going to start off x times x, that gets us x squared. X times the other term inside the parentheses, positive 3. X times positive 3 is positive 3x. Now we'll move on to the other term in this first set of parentheses. Positive 2 times x is positive 2x. And then we multiply by the positive 3, so positive 2 times positive 3 is positive 6. So I've multiplied each one of these 4 terms by the other terms inside the other parentheses. Notice how I did not multiply this x times 2, and that's because we're not multiplying them, we're adding them. What we're multiplying is this set of parentheses times the other set of parentheses. So that's what I did, and now the last step is to see what can we combine. We have 3x's, positive 3x's, and positive 2x's. So combined, this makes positive 5x's all together. And then the other terms stay the same, and this would be the final answer. The same rules apply no matter how big the polynomials are. We're still using the distributive property to multiply each term by all the other terms in the other set of parentheses. So in this problem, I would be doing 6 sets of multiplication. So just to walk you through how I would do that. First we have 2x times 3x squared. So 2 times 3 is 6. X times x squared. In total we have 3 x's that we're multiplying, so x to the power of 3. Next, 2x times positive 4x. 2 times 4 is positive 8. X times x is x squared. Next we have 2x times negative 4. So positive 2 times negative 4 would be negative 8. And then we just have that x, so negative 8x. Then we have negative 9 times positive 3x squared. Negative 9 times positive 3 is negative 27, and then that x squared. Negative 9 times positive 4x, negative 9 times positive 4 would get you negative 36, and then the x. And then negative 9 times negative 4, negative times negative is positive, so positive 36. Okay, that's a little long. Let's definitely combine some things here. So first we have 6 times x to the power of 3, and that is the only x that has an exponent of 3, so I can't combine it with anything. I will leave it like that. Then we have x squared and another x squared, so I can combine those. Positive 8x squared plus negative 27x squared. So if I combine positive 8 and negative 27, that would get me negative 19x squared. Then let's see what else we have. We have x's, just an x and just an x. I can combine those. Negative 8x and negative 36x all together would get you negative 44x. And then lastly, we have this whole number by itself, and that is the only whole number, so I will just leave it as a plus 36. Nothing else can be combined, so this would be your final answer of the multiplication. So yeah, that pretty much is the general gist of how you multiply polynomials. Just make sure you multiply everything in the first parentheses times everything in the second set of parentheses, and then combine any like terms. If you're interested, this is another example where you have different variables. Again though, we'll follow the same rules. So I'm going to go through this one. 3z times 11z, 33z squared, 11z times 2y, we have positive 22. Z and y can't combine, so we just have to leave it as single variables, y times z. Then we have negative 5y times positive 3z. Negative 5 times positive 3 is negative 15. Y times z can't combine, so we leave it as yz. Then we have negative 5y times positive 2y. Negative 5 times positive 2 is negative 10. Y times y squared. All right, let's see what we can combine. Well, these two terms, both of them have both of the variables y and z with no exponents. They look exactly the same, yz, yz. So when I have a scenario like that, these can be combined as well. Even though they're not only one variable, if they have the same set of two variables, yz, yz, and both of them would have just an exponent of 1, we can combine those. So this would stay the same. I have positive 22yz's minus 15yz's for a total of 7 positive yz's. And then the y squared, that's the only one that has a y squared by itself, so we leave it like that. And this would be the final answer. That's just another example of what possibly you could see at some point when you're multiplying polynomials if you have multiple variables. For now, we'll just focus on one variable, but I just want you to be aware of this is out there in the world. Anyway, if you have other questions, check back in with the rest of the class as they're going through it. Otherwise, go ahead and start the practice for today now.